Welcome to Unit 2, Integers. In this unit, you will learn how to multiply and divide integers, use the order of operations with integers, and solve problems involving integers. Topic 2.1, using models to multiply integers. We can think of multiplication as repeated addition. For example, 5 times 3 is the same as adding 5 threes. Or as a product, 5 times 3 is equal to 15. How can we think of this problem, 3 times 5, using models? One way is to use a number line. Take 3 steps, each of size 5. So 3 times 5 is equal to 15. That would look like this. 3 steps of 5 brings us to 15. Another model that we can use to represent this problem is to use tiles. And we can do that concretely on our desk in front of us if we have tiles to work with, or we can simply draw them and do it visually. So 3 times 5 can be represented as 3 groups of 5 counters. So I can simply draw 3 groups of 5 counters, and I have a model now that represents the product. Now, what if we're given a problem like this, where one of the two integers is a negative integer? We can still use a model to represent the solution to that problem, but we need to be careful now when we're using tiles, because a negative integer should be a different color than a positive integer to represent that it's negative. So what we should always do when working with positive and negative integers is create a key that lets us know what color represents what type of integer. So let's let black be a positive integer and we'll let red be a negative integer. And then we can use the same model to represent this problem. So 4 times negative 3 can be represented by 4 groups of 3 negative integers, or 3 negative tiles. Okay, so the solution to this problem here would be negative 12, right? Keeping in mind that red means negative. We can solve that same problem using a number line model like this. So what I've done is I've drawn a number line, I've put a stick person on the 0, and I've put the person facing forward, facing this way into the positive side of the number line, because the first value I have over here is a positive number. Then I'm going to take 4 steps, but each step is going to be negative 3. So just think about that. You're going to take a negative step. That means you're actually going to be walking backwards. That would be a negative step, right? The opposite of a positive or a forward step. So the stick person is going to go backwards 3 for each step, and they're going to go 4 steps. So you can illustrate that like this. 1, 2, 3, and 4. We end off down here at negative 12, which is the same answer that we arrived at using the tile model. Now, if we're given that same problem, but only backwards, so where the 4 is negative and the 3 is positive, we can actually use the same number line model and just think of it backwards. So the negative in front of the 4 would tell us to face the negative part of the number line, okay? And the positive 3 would tell us that we were going to be taking steps that are forward. So if we're facing this way and taking positive steps, we're going to be walking forward, walking this way. So we'll just take our stick person and we'll make them go 4 steps of 3 this way, and we'll end up down here at negative 12. So it doesn't really matter which way the problem is presented. the answer is still going to be the same. Another way to look at a problem like this is to use a bank model. A bank model is simply visualizing the problem using a bank account. Okay? A bank account can be represented by this circle here. So imagine this is a bank account. Okay? We're going to make deposits, meaning we're going to put value into the account, and we're going to make withdrawals. We're going to be removing value out of the account, just like a real bank account. Money goes in, money comes out. You deposit or you withdraw. So what this problem is telling us to do is to withdraw 4 sets of 3. Now you're probably wondering, how can we withdraw 4 sets of 3? There's nothing in the bank account. Well, that's a great question and a great point. In order to withdraw, we must make a deposit first. And we can make deposits that are known as zero pairs. What I'm going to do is I'm going to add I'm going to add 4 sets of 0 pairs into my bank account. Now, a 0 pair is simply a pair of integers that cancel each other out. When you add them together, they actually add up to equal 0. So this, for example, right here would be 1 0 pair. We have one positive and one negative integer. Together they make 0. So they're called a 0 pair. So I've added enough of those into the bank here so that I can actually now make my withdrawal. All right? So now I'm going to withdraw 4 sets of 3 integers. Now 3 is a positive number, so I'm going to be withdrawing the positive ones. So what I'm going to do is I'm going to withdraw these positive ones. I'll actually just cross them out. That would be 1 set of 3. I'm going to remove this set of 3. That's the second set of 3. I'm going to remove this. That'll be my third set of 3. And I'm going to remove this. That will be my fourth set of 3 that I have withdrawn from my bank. Now, what's left over? Well, we've got 4 sets of 3 red tiles. These are our remaining value in our bank account, and that is the answer to our problem here. So 12 reds would be negative. Our answer is negative 12. We can use that same model for a problem where both of the integers are negative. So in this case, we are asked to withdraw 4 sets of negative 3. And in order to withdraw anything from this bank, we have to actually make a deposit. We're going to deposit 0 pairs. So deposit as many 0 pairs as it takes so that you can withdraw what you need to withdraw. In this case, it's 4 sets of 3 negatives. Okay, so I've got 4 sets of 3 0 pairs here, and now I can remove the negatives. So I'm going to actually remove these. It's my first set of 3. It's my second set of 3. My third. And my fourth. And this time I'm left with 12 positive tiles. So that means that my answer is positive 12. So you can use a number line or tiles to represent the multiplication of integers.